All right, it's time to go. Started a little bit late, but it's fine. I had to spend a very, very, very long time. You saw all the VoIPs just now, all those different little Unreal solutions. God, it took so long to finally just. I had to update like 16 things, and I don't think any of those were even the solution. I think I just had to right click and verify the Unreal Engine. And I only did that after like 2.5 hours. So, very fun. Probably longer than that, honestly. Much longer than that. Trying to find the music real quick. Wait, why is it? Bro, just put me in the fucking playlist. You don't have to start playing it. Hello? There we go. Of course, fucking Chrome's bugging out. It's great. Okay, hold on. I have to fix it fast. Like, why the fuck is... Bro, turn show bookmarks off. It wasn't me. Okay. Alright. Well, at least I'm back to fixing Unreal stuff. Now I have a game that works. It's multiplayer. It's... It was working for a sec, but then it stopped. I don't know why. I'll have to figure that out. But you can't start a server anymore. I don't know why. I have to figure that out. But it should be multiplayer. The voice should work. You should be able to connect to each other. You should be able to do a lot of stuff right now. Okay. So now, what do we got? We have a predetermined array, and then, oh god, I hate that I know exactly what's going on here. But when it comes to Unreal and there's 4,000 files, no idea. I'm just hoping. Search for 7. 7 is indeed at index 2. Stop at 225. And we could just put all this in a helper function too. Why is it cool? It shouldn't. Yeah. Cool. Works for me. Cool. We have a function that prints the array. We have a function that returns the index. You could also do -1. I'd rather do standard optional. Getting a number from the user. I did the same. You could do this different ways. I did it the same way. Anything in here I could take or do better with? We get a number, we do this at least once. Oh, and the point is that you keep doing it while the user... Oh, that makes sense. So instead of it being while true, that makes sense. Well, makes sense, because if we do this, we're not returning a value. You see? Because we would say, okay, create a user int, create an integer, and then have a do while loop. And in the while loop, we can do this. Well, and return only there. But if we do that once, and then, well, it's fine, I think. Cool. Works for me. Yeah, I did it like that. Containing non-int numeric values. Okay. Well, excuse me. Non-int meaning double as well. Excuse me. I mean, we'd have to switch this to double, right? We can't just leave it a T because we're not explicitly calling it. Or well, because it's get user value. Yeah, and we don't know until the user enters, so I think we have to put this as a double. And then where's our standard optional? Hold on. All right, hold. Oh, wait, this should be the index. Hold. This should still be an int. Duh. Where? Line 65? No, this is not user index, retard. This is user value. This should indeed be double. My comment was just wrong. This is where the index part is. It should really be, or well, or find index. I mean, it really doesn't change anything here. We care if it's negative now? I don't know. Sure. It just continue as long as it's not negative. And we are checking equivalency here, but we don't have any operations happening on them, so it should be fine. We're just comparing two floats with the equivalency. Should be okay. In the event that it doesn't, we could do some absolute value, what do they call it, some alpha or some, there's like a Greek letter that they use for saying it's the minimum acceptable difference, like delta. Yeah, we're still printing whatever the array is. We already had that as a template. Yeah, we're returning an integer because it's that. We still need template because we don't know what type the vector is going to be. Yeah, it's fine. Okay. Write a function template to find the largest value in a standard vector. And if the vector is empty, oh, because if the size is 0, wouldn't we just be returning? What even happens if it has the size of 0 and it doesn't have an index? Do I just create a standard vector and return the 0th index of it? Of that same type? That's by const reference, we can find it. Okay. Oh, the default value for the element type? So that should actually be here. We'll just return max. Okay, that's fine. It loops through each time and then, right? Oh. And actually this should really be this should be initialized as and we should probably catch this first too. We say if vector.size is 0, and then return what? A temporary okay, so this still works. Turn a temporary, so empty, turn the type's default value. And if not empty, initialize with first index. Two elements. Compare elements. Size. Okay. This should be vector 0. Boom. Yeah. Because the problem was we were initializing it with 0. And because we have negatives, well, duh, 0 is going to be greater than all of them. We don't want to return 0. In this case, we want to return the most positive one, so negative 13. This can be const expression, I think, because I don't see anything that we're doing explicitly at runtime. And sure, in this case, it's not const eval. If we did const eval, it would be bitching because it's not receiving a const expression. But this is fine because it could still activate it. It could still execute at runtime. Cool. Same. Yep. Exact same thing. Exact same strategy. Verbatim. Yep. Yeah, exactly. Yeah, because it'll return 0. Just like if we initialized it with 0, but the values were all greater than 0. And the function was called min. Make sense? Excuse me. Makes sense. Just say if it's divisible by vector bracket 3, then print the other vector, the print words 3. talking about? Oh, well, yeah, it shouldn't. Wait, what? What is he saying? If if the arrays program should assert. Well, I mean, it would assert. We know this because, well, at least in Visual Studio, it'll assert when we access outside the bounds of an array. I mean, we could check. We could say. In this loop, we divide by each one of them. And if it's divisible by this one, let's see. Oh, so we have a loop that counts up to 150. And for each one of those, it loops through each one of these possible ones and checks to divide. And if it does, it should print this one and then this one, whatever. And once it gets done with the end, oh, and if it does boom, let's see. I mean, we could have a Boolean to check if it is printed or not. And each time we set it, let's see, like for each, in the for loop, we set it to has not printed yet. And then at the end of the loop, if it has printed, then it shouldn't print the number. Okay. Yeah, I can try this. Fizz bus. Okay. I mean, should we just create it here? I guess so, right? Standard vector for each of these guys. Three, 5, 7, 11, 13, 17, 19. Then const standard vector, standard string view. Words, or buzzer words. Fizz, buzz, pop, bang, jazz, pow, Boom. There's 7 of them. Cool. That's it. Okay, 4. I just start at 0. I is less than. We'll just start at 1. Through 150. Each of these will say as printed word false at first, and then we'll say int what tests. Test, and we'll evaluate, or we'll initialize it to be how many other? There are 8. The fuck? So the size is gonna say 7, but we need up through 6. Or we'll hold on. Oh, well, we could say. Oh wait, this is fine. What am I doing? So we got int current the test. Or we got int what index round? I don't know. I don't really know what I want. While round is less, or while I like test. While test is less than divisor. I guess divisors that size, right? Okay. Yeah, we're not using these yet. Oh, here we go. Game max. It specifies game length. So we'll do this, and then at the end we say if not has printed word, then output I. Could say so if not 0, so if I and honestly I like none better. If the number, or we could say, well, yeah, if the number, how do we want to do this? Like this? If the number remainder divisors test is not 0, or we say actually if it is 0. So if it is divisible by it, then output divisor, well, divisor words 0. And this should really just be a standard size T. Hold. Uh-oh. Whoa, whoa, whoa. Hold. Oh, duh. This is just, bro, why am I doing 0? Test. Hello? Let's check the answers. Let's go, son. 1, 2, fizz, 4, buzz, fizz, pop, 8, fizz, buzz, bang, fizz, buzz, bang. Fizz, jazz, pop, fizz, buzz, 16, pow, fizz, boom, buzz, fizz, pop. Let's fucking go. I'll take it. Anything crazy? Cool. Let me bust this thing down. We are doing runtime stuff, so I can't do we can't make this guy const expression. I mean, we may as well have these in here. I mean, does it make sense to do them? I mean, we could put them in another namespace too, but if they're only ever used here in this one function as a game, there's no point cluttering up by having another namespace, right? Just put these in their own files. Cool. Excuse me. Cool. That was enjoyable. Fuck. All right, I gotta turn this down. Going too crazy. All right. Arrays, loops, and sign challenge problems. Where were we even at just now? Arrays and loops. Oh, sign challenge. Okay. Oh wait, I didn't even look at his solution. See, yeah. Fuck. I needed to assert in there. I needed to see assert that's correct. To assert that the length of. Oh, so the point is that you would pass in two standard vectors, one for the divisors, one for the divisor words, the user would. That way you could put in any other number you want to check. Oh, maybe now there's two. So fucking every number, every other number at least is going to have that one now. And then, oh, you got another and another. And the point is that we're asserting to make sure that the user is entering two equal vectors so that we would assert it out either way. So in the very beginning here, it's going to have, wait, huh? Oh, okay, I skipped it. In the very beginning of the solution, I imagine in the game, it's going to have an assert to make sure that, hey, are the vectors actually equal length? I'm guessing that the user's going to have to put it. Here we go. Here's Buzz. Here it is. So one, wait, what? I mean, I guess the point here is that you put in the assert that, well, you could do either way, dot size, whatever. I don't really like the static member function syntax, really. I prefer to use the regular member function because I want the size of this. I don't want to do size this. I want to do like this thing size, like the woman's weight, the car's color, not the color of the car. Not fucking Spanish, brother. Pelo de moreno. Something like that. Moreno. No, man. Brown hair, brother. My hair's color. Not my fucking color of my hair. What? The size of the word list? Oh, no. Alright, well, I mean, you could have done it either way. You could have made the user pass it in, and then check it that way, which would have made more sense. I mean, I guess you may as well put this here to check, because if you change the game, then you want to make sure that when you're running it, that hey, by the way, one in a release build, this gets compiled out, so it's okay, but it's not bad. Oh, size 2-2 makes sense. Yeah, so far that's what we're doing. I'm curious if that's what we're still going to be doing. I don't remember doing that in. I mean, we did loops for sure and arrays for sure. Wow, fuck, did we? I'm pretty sure we did in the little like 2 months of C I was doing. I don't remember signed unsigned mismatches. Oh, but then again, they're just warnings in our cases, so I just have warnings treated as errors. My compiler's more strict, so makes sense. Okay, it's the exact same solution, almost verbatim. Well, basically verbatim. It's just the only difference here is one, I forgot the assert, and two, how I would implement the assert, and three, yeah, and that's it. Honestly, this is perfect for solving. This is like solving music. I need some study music, just different new information. Head's bopping too much, stuck too much in that rhythm. Oh fuck! This is the same piano as the JoJo, can then black hair guy's dad fight. Oh, oh, this goes too hard. Okay. It's too hard. It's too hard. I can't. And this is English. God damn it. Why did I find so many bangers the last 2 days? Chill. 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 Alright, it's fine. Unsigned and why we avoid them. Oh, we already went over some of this last chapter again. Generally prefer to use signed. Makes sense. Yeah, because we get underflow, overflow. Well, you're not going to get overflow, really. You're going to get underflow, but. Well, you would get overflow if you pass it to an int instead assigned, so. We said, hey, we generally avoid these. By the way, fuck up. Any issues are, let's see what we've got. So we have an array. Okie doke. We're printing reverse. We're printing reverse, so we're counting down. We have a size t index. Oh, here it comes. We're doing this while it's greater than or equal to 0. The problem is at some point, a size t is going to get down to 0. It's going to be decremented again. You'd think it would be -1. Instead, it's going to be 4.3 billion. Well, actually, fuck. It's going to be even bigger because it's long. It's going to be like 16 quadrillion or something insane. Yes, it's going to be crazy. And so if we step through it, if we do this stepwise, boom, pass this guy via, yep, const reference as you'd hope. And it accepts different types, so it's fine. And we say, yeah, we're just printing it in reverse. So we're starting at the max index. So we're doing max index -1. So size, which is max -1 to get the final index. This is 8, so we're getting 7 in this case. Okay. Start 7 while it's greater than or equal to 0. Do this, -1, so we print it, space, decrement it, 6 now, 5, 4, 3, 2, 1, 0. -1 forever, because -1 is really infinite. It's really super positive, which means we can decrement it all the way down again. Yep, makes sense. Let's print it. Oh, vector subscript. Oh, it's just doing a nice little assert action the exact same way as before. That's good. Oh no, do not delete everything in standard vector, please. Do not. Not what I want. Okay, cool. It did it immediately because we have an assert and we're not in a release build, so the assert stands and it is asserting, hey, you have to use a valid index. So it's while the index you're using is 1 is less than 0, and 2 while it is, well, actually, rather it's, well, yeah, it's, I mean, sure, while it's less than 0, but we can't do it because it's unsigned, so there's no less than 0. It's really just while it's greater than, while it's equal to, or while it's greater than or equal to the size, really. Makes sense? One. Always true when it's unsigned. Makes sense, yep. The other problem, aren't these the same? Am I being stupid right now? 2 problems. The loop continues. Loop continues as long as that's positive, and we'll never get a negative as we keep decrementing and unsigned, so it's always like that. Yes. And the second is that when we decrement it, oh, the point is that 1, the loop goes forever, and 2, the index is the thing that's being decremented. That's our loop counter. So we're actually going to access something outside of the range. So 1, the loop goes forever, and at some point in that loop, at the same time, actually, of the loop going 1 time more than we want, that's the first time we access an out of range value. And then we get it again, and again. It wrap around to a large value, which we use to index it, and this is out of bounds exactly. So it's undefined, but in our case, we have an assert, so it's actually defined in our case, but only because we have an assert. If it was at release and there's no debug, if it got compiled out, then I don't know, it might be screwed. And it might make sense to do this and assert that the vector isn't empty in the beginning too. Oh wow. I gotta re-like this one. Just because of how great it is. I'm re-adding it to the playlist too, just to bump it in there. You know, you're gonna comment too. Fuck yeah. Oh, I have 40 minutes till bedtime. It's actually time for the self-quiz. Self-test. Using a signed type for a loop. Okay. Curious to see what the next stuff is, but we gotta go. We gotta do self-test. Excuse me, wrong website. No! Fuck, I have to do another prompt. Oh, isn't it Control-Shift-V? Yeah. I think it might have done it twice. No, it didn't. Good. Oh, fuck. It's comprehensive. It's nice. Alright, what more? Oh, what's the voice? Oh, GG. It was on the wrong one. Well, voice has been fucked the whole time. Great. Oh, fuck. Okay. Okie doke. No! Oh, my fucking... I've been swearing a lot recently. I need to chill out a little. What the fuck are these fat asses downstairs doing? I'm gonna go critical mode here first. And then we'll swap over to like the big bad music. Arrays are used in loops to access different related values without explicitly writing them, i.e., we can use the loop variable to index the array to get each loop iteration's value that it needs to use. Loop through students to check if each check who's present. Loop through mags to find the one with the most ammo and load that one, etc. That's a good answer. Move semantics are the rules that govern how data is moved from one owner to another. I.e., we still haven't even seen it. We still haven't even done it. We've only seen that it could be done. Haven't used it yet, but if the function returns by value, well, let's see. If the value being assigned is temporary and thus will be destroyed at the end of its expression. If it's temporary, the type is movable and no other reasons disallow moving the value, then move semantics can move the value from the object it's owned by to being owned by the object it's being assigned to, or, well, it's being assigned its value, assigned or initialized with its value. Cheaper to move value by changing ownership via pointers than on the pointers under the hood and actually copying values. 184. Let's say vector be a const reference or reference, depending if we want to mutate them or disallow mutation. Oh, if we use a non-constant expression, signed integer to index a standard vector, we get a warning or compiler error depending on warning settings due to unsigned signed mismatches, potential narrowing conversions. Which makes sense why the const expression makes it okay, because const expression will say, yo compiler, look at the numbers. Look, if they're wrong, then error. Don't just error like a dumbass first. Like a helicopter parent, man. Standard vector is a class template and type of array that can change. The size can be changed. So what else does it have? Size can be changed. Elements accessed directly. And elements accessed directly. i.e., an efficient, easy to use array can defined in the standard library, template library. And I guess that is a standard template library for sure because it's a template. A container in C++, fuck. How are we defining this? It seems like this is really associated with encapsulation. Fuck, why are they insufficient? Container is an object that holds may hold multiple dies of a certain or of the same type. I'm not sure if all containers let us access them all, or like something like that, including arrays, like standard vector. Why are arrays insufficient? I'm ignorant about the insufficiency of arrays. and use cases. If you must access objects by name, you can't with arrays, since their elements are accessed by index. But I'm not sure what the real shortcoming is. A ref qualifier. Oh, fuck. I did not get asked this yesterday. A ref qualifier. Oh! A ref qualifier is a reference type qualifier that goes. Does it go after the const? I mean, it goes between. Well, hold on. Can I do it for anything? Void test. Not allowed on non-member functions. Between the parentheses and braces for member functions, letting us call member functions with overload them to have versions accepting R value or R value or L value references. Since we might want to handle them differently. What was the example there? If we pass a reference, wasn't it I don't remember if it was the constructor or not. Let's say it's not the constructor, it's something else. We pass it a reference. Oh, because if we were passing it an L value, then we can return the L value, otherwise we return by value. If we pass by L value reference, we can return the L value. But if we pass, return the L value by reference, possibly non-const. We can't if we pass by R value reference, since R values can't persist through function calls, through function returns. A friend class or friend classes and friend member functions are classes and member functions declared a friend by another class, which gives them access to use said class's private and protected data members. This breaks encapsulation since we're giving access to part of the private since we're unhiding data members, might have efficiency or syntax benefits. Careful. A friend non-member function is like a friend member function, just not declared in a class. Gets access to the class that made it a friend. Well, the class that made it, or that declared it a friend, gives the gives it access to it, direct access to its private protected data members. A static member function is a function declared static in the class definition, but defined outside. Well, I don't think it has to. Class test. Private, nothing. Public, sure. Static, void, test. And then we could say, uh-oh, here it comes. See, it works fine. It's the static member variable. I'm trying to fix my headset. It's easy to just shake it and like knock it back a little bit. That's what you see. I'm not fucking tweaking. I'm just doing this to like push it up a little bit here or adjust it there because I'm a little weirdo. It's the static data members that can't be defined or can't be initialized on the inside unless they're inline. Otherwise, they have to be declared inside but defined elsewhere. Unless there are certain values that can be const, I think, something like that. Declared static in the class definition. Letting it be called, well, lets it be called by resolving the class's scope and scope. Disallows it from accessing non-static data members, and there's a question I don't know. Can it access other functions, non-static data members? I don't know. Excuse me. We'll say accessing its classes, non-static data members, and can be called without referring to a, or can be called without, and doesn't have to be called on an object, on a specific object. Preferred to not. I mean, because it could still change static data members, which could still change the existing ones, but it can't change, well, not call it on a specific object because it only affects static data members, not ones owned by each class object, because those are shared. Static member variable defined inside the, or well, declared in the class definition, but defined outside unless inline, then it can be defined inside. Fine. And is shared among all objects of the class, i.e. all player class objects would have access to the static data member player world name. Standard string. And if one changed it, all objects, all players would see the updated value. Put a class or template clause before the class template definition, and member functions won't need their own unless defined outside the class definition. At 174. Oops. A destructor is a class member function called when a class object is destroyed, providing a cleanup opportunity. Nested type is a program defined type like an enum, or rarely another class defined inside a class definition. Defined and usable, well, defined inside a class definition. What was it? There was a phenomenon where, yeah, we can, because of that, we can instantiate the inner class or the nested type. There was an issue there or something. I mean, I know what it is, but I can't think of the issue. It'll come up maybe. Organize classes by defining them in header files with one line member functions. Oh, great. With one line member functions defined inside, and more complex member functions declared inside and defined outside in the classes.cp file, or make the functions. Well, I think the member functions are for header-only libraries, define member functions defined outside the class, or will make member functions defined outside the class definition inline, adhere to the one definition rule. Now we're at the banger music now. Member function chaining is when member functions return a dereferenced this pointer, which returns the class object member function was called on, letting us call another member function on that return value, since the class object is the return value. The hidden this pointer is a pointer to the class object itself that is implicitly passed to its member functions, letting us use shorthand identifiers. Well, use its data member identifiers as shorthand instead of using them through the this pointer, i.e. the this pointer is necessary with the compiler, but we don't have to explicitly add it unless we're doing member function chaining. Const expression aggregates and classes are fuck. Oh. Yeah, but isn't the point that it has to be, it's the class object itself, so we could have class test aggregates and classes are user defined or program defined types that are created or created compiler creates, resolves that, compiled them. It seems straightforward enough. A converting constructor is a constructor that fuck. Oh. So constructors are converting constructors by default, right? Because they take an initializer list and convert it into an object. Converts values from one type to another. Constructors are converting constructors default because they take arguments and convert them into a class object. I guess copy constructors aren't, though, because the type is the same. They take one type as an argument and yield a class object of the same type. Explicit disallows calls to member functions that yield implicit conversions. Copy elision. Compiler's process of removing unnecessary copies. Like when creating an object in a function, like passing value or passing an object by value to a function parameter, which initializes another variable, which gets returned. there might not be a need to, well, the copy from the parameter to the other object might be redundant, as might, well, let's see. Passing to it, cool. They're redundant, and then we're just copying back. So that copy might be removed by the compiler. A copy constructor is a constructor that's called when initializing or assigning will hold. Because it's called when it's constructed, not on assignment. When initializing a class object with a class object of the same type. You should perform or use a member initializer list to initialize each of the new object's members with each of the past object's members. Temporary class objects are class object R values. That are destroyed at the end of their full expression. It seems like it's simple enough. A delegated constructor. Oh, I haven't used this much. A constructor that delegates its member initializer. Well, its construction process to another constructor, letting us by passing that constructor with more, that has more parameters, plays as arguments, letting us handle more constructor argument combination. Could do the same thing ish with default arguments. The default constructor is the that initializes, well, the class objects data members of their default values. Think something like that. Member initializer list is a structure that the constructor uses to initialize data members more efficiently than assigning them value in the constructor body. Constructor is a function called when a class object is created, letting us preserve invariants and perform other related setup. Okay, I gotta go to bed soon. Boom. Ow! Oh, good. Feedback for each. Good, 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 good. Oh. Yeah, because I totally missed that. Loops allow systematic traversal. Bop, 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 bop. For searching without repetitive code. Makes sense. Yeah, it's fine. Sorry, I'm tired and didn't have much time. I didn't want to go too hard into each. We cheaper the copy because it transfers ownership instead of actually duplicating. Move doesn't just apply if the type is movable. It happens if we use an R value or a return local in a move constructor. Hold on. It happens if we use an R value, so some object, or a returned local. Wait, what? Okay. In a move constructor operator is defined. It seems like it happens more accurately than, or more often than I know, but I haven't even used it yet. Source object is left in a valid but unspecified state. Oh yeah, because it's also is valid, but so what? Empty? The one where it was created and then now it's empty. We haven't even used that yet. Correct because we expanded. Oh, here we go. Can also pass by value intentionally if make. Hold on. I don't know what you're talking about. Well, you're even pass by value. So far I haven't even seen pass by value. Problem is comparing sign and unsigned can yield unexpected results since wraparound instead of going negative. Well, I mean, it makes sense. I mean, it goes either way though. I mean, there are two issues there. Well, I mean, sure. I mean, the problem is that if we're decrementing, we're not expecting it. But that's just a standard signed, unsigned thing. The real thing here is if you're using it right, that the compiler's bitching about it. I think it's fine. Because if it wasn't an issue, then I could still just have asserts and it would be fine. But the real issue still is then the compiler's just bitching at me. Then again, maybe I'm more biased to say that because I have a more strict compiler setting. It handles memory allocation and oh, true. So it can, I guess that makes sense. So if it allocates more memory for putting in more members or more elements, and then it removes them, they're destroyed. Key shortcomings. Here we go. I'm not sure. Oh, arrays are fixed. Regular arrays, they don't have bounds checking. Well, I think they said that I thought we said that certain ones do bound checking. Standard vector. Oh, we're talking about arrays, literally C-style arrays, not just regular arrays. Okay. I mean, standard vector still doesn't even do bounds checking by default. So, but the point is, a C-style is fixed size. Okay, fixed size as well, and that same thing. This itself can become. Oh, hold for that. This can also be that. This. Meaning that the object itself? I don't even know how that works. You know, returning from an R value qualified member function. Returning from an R value qualified member function. Yeah. Enable move semantics. Oh, yeah, because we're passing by values in this case. That makes sense. Okay. Enable move semantics. Okay. Printing is, yeah, it's only reciprocal if both of them do it. Yeah, we already know this. It's fine. And static can't even access this. Interesting. We could still call it as an object.static member, but it actually can't even access this. Gotcha. It's that the non-members and, well, what else is it? Oh, it's that friend and non-members need to be passed explicit ones because they don't have this pointers. It's that static can't even use this. Gotcha. That makes sense. Excuse me. So we kind of just got lucky that we're allowed technically to call them on an object when we really shouldn't. Okay, I was wondering why the timer didn't go off. I actually just didn't even set it for bed. It must be defined outside unless inline has one shared instance. Yep, makes sense. Oh, and true. We have to qualify. I forget that I haven't done too many class templates. You also have to qualify it so that the compiler can look at it and say, hey, let's do some deduction here. Gotcha. So, because in the event that you are specializing one, you need to specify, hey, this is for the generic version or the specific. Okay. It should also release resources. Yeah, I don't know this yet. Runs out automatically whenever it's deleted. And going out of scope, same thing. I mean, it has to be is deleted, not out of scope, because during out of scope, you are deleted unless it's static. Okay. Makes sense that it's called in reverse. Well, I don't know how that works though. Well, yeah, if they're in the class, then you're good to go. Yeah, it makes sense. Duh. I don't even need to mention that. Well, duh. Well, yeah. If it is a purely inline member function, well, yeah, because the inline definitions have to be included everywhere. So it would have to be in a header file. But you'd only do that if that was already the case. Yeah, return this. Okay, set this, dot set this, dot set this. Oh yeah, true, because the constness depends on what type of object it is. Because if we call a const function and it returns this, then it's returning a const this. So then it can't do a we can't call a mutable this after a mutable function. It's an R value within R. Hold on. This is an R value within R value qualified member functions and an L value otherwise. Oh, okay, interesting. It would make sense if we're saying that it can only accept them, but I'm surprised that the compiler puts it in like that. It makes this differently. And the key is but the key is conditions. All constructors and members must be const expression compatible, and all initializers must be, yeah, meaning that nothing in them is called that must be runtime, and everything must be evaluatable at compile time. That way, they're just optimized out as values. Yeah, it makes sense. I mean, I think it was self-explanatory, which is why I didn't go super full into it. Like, oh, okay, duh. Yeah, if we make any variable const expression, the compiler is going to optimize it away and just use it as value. Well, same fucking thing here. Topic constructors are a kind. Oh, because they convert from one type, from the same type to the class type, but it's the same type. I don't know what you mean. Oh yeah, because it also disallows regular assignment, the equals sign assignment operator. So it prevents some kinds of implicit. Hmm. Guaranteed return value optimization. Okay, noted. So we might have to also declare a default move constructor. Okay. Oh, because the move constructor is probably by default the copy constructor, I guess? Sounds like they're both the same. So if I create an X class object and another in a Y class object, and I assign the X class object to the Y, then it's actually moving the X to the Y by default because we're assigning by value. So that, well, I mean, we're basically passing it by value. Interesting. Hmm. You can only delegate to another constructor of the same class, not a base class. I don't know what that means. I don't even know what a base class is. Makes sense. It's default, yep. Oh, and because we can't assign them in the body, we have to initialize them. I guess we just can't. Okay. So const members. Oh, because they would be default initialized, even if not mentioned in the member initializer list, they'd be default. And then we'd be assigning to them in the body, so we can't assign to them in the body. That makes sense. Well, this is also just a syntax thing. They can be overloaded. Makes sense. Yeah, based on whether they're ref qualified or not, and based on their parameters. Yeah, bop bop bop, not in the list. Which I mean, you'd want them to match anyways. Nah, it's cool. I'm good now. Thanks. What models does this have? Oh shit. Oh my god. 10 times as many citations. Holy. Damn, it's kind of cheap. 20 a month. But I'm a broke ass. I will never buy that. Cool. It's just good enough for me. Okie doke. That's it for now. More tomorrow. I can do better.